and thank you for joining our Mecademic MicroDASH series product launch. My name is Sam, and I'm the marketing manager here at Mecademic and your host for today's webinar. During the next hour together, you will have the chance to get to know us, Mecademic, and of course, our guest of honor, MicroDASH robot, as we present its key features, how it stacks up against the competition, and a quick demo via the Mecha Portal. After which, I'll be joined by our panel of experts as we have 3 partner integrators and our very own director of applications, joining us to discuss overcoming micro-automation challenges by rethinking industrial robotics for small manipulations. Again, we are trying to bridge. A quick shout out to our sales area managers, Louis Lapierre, who will be moderating today's panel, and Naveen, who's ready to answer all your questions and comments during the webinar. So don't hesitate to use your Q&A features at the bottom or at the top. For the YouTubers, comment section. So welcome to the future of automation. I am so thrilled to be introducing you today to Mecademic, a company that is redefining the landscape of industrial robotics through innovation and a relentless pursuit of excellence. Recognizing the need for a programming architecture that is both sophisticated and user-friendly, we saw an opportunity to bridge the gap by pivoting into industrial robotics, while keeping our origins, including the openness, simplicity, and flexibility of our robots. Don't fret, Mecademic robots are as comfortable in the lab as they are on the production floor. But our success speaks for itself. We've garnered recognition and accolades, including Deloitte's Technology Fast 50 in 2021. And this year, we got Canadian Business's Best Robotics Innovator, showcasing our sustainable growth and commitment to pushing the boundaries of innovation. We're so proud to be collaborating with some of the biggest names in biotech, medical devices, and electronics. With over 30 Fortune 500 companies that trust Mecademic. You wonder why? Well, it's because we deliver on our promise of innovation, reliability, and performance. So building upon the success of our flagship product, the Mecha 500, let's see how it translates into the SCARA and what it sets apart. So starting with its ultra-compact build, it's 27% smaller and 46% lighter than its closest comparable model, making the MCS 500 a game changer thanks to the embedded controller, more on that later, and the fact that it's batteryless, keeping our signature compactness at the forefront of our innovative design thanks to the cutting-edge batteryless high-resolution encoders. You can streamline your processes without the hassle. Now, speaking of the embedded controller, Mecademic's new SCARA has the smallest footprint on the market, giving you more space, and we all know that can be more money. Speaking of which, for some or a lot, I see some integrators in the audience here, space-saving features equal gain in ROI. Well, guess what? With Mecademic's new SCARA, you won't hinder the robot's range of motion. In fact, thanks to our design, you could reach more of the workspace than the MCS 500's closest competitors. Now, many people associate Mecademic with precision. And just like our other products, our new SCARA has a precision repeatability of 5 microns, making it the most precise industrial SCARA robot of its range. To put it in perspective, a blood cell is between 7 and 9 microns wide. Just food for thought. Now, by providing our users flexible mounting, meaning that you can have a tabletop or ceiling mounted, we allow you to maximize your space allocated to your application. Now, don't forget, if you have any questions, please don't hesitate to use the Q&A feature or on YouTube, the comment section. You want more? Enhanced performance? Check. Same league as the top comparable small-size SCARAs, our MCS 500 delivers great performance without compromising on our renowned precision. Now, new to this series is the Smart Vacuum and I/O module. Fully embedded into the control of the robot, you just need to insert the module under the robot base, and it's ready to go. The model has 8 digital inputs and 8 digital outputs. It also can control a suction cup, detect the negative pressure in your tubing, and eject air for faster release. Then last but not least, our SCARA, of course, like our Mecha 500 robot, is software agnostic, which ensures that you can seamlessly incorporate our products into your workflow without disrupting your production line. Our knowledge base even has examples to help you get started, thanks to our applications and support team. So tell me, what features are you excited about? In the meantime, to give you a better feel for the MCS 500, we'll be using the Mecha Portal to showcase different commands and the overall ease of use.
we have built a simple pick-and-place demo to showcase the MCS 500 in action. So in order to start, we first have to access the Mecha Portal, which is the intuitive interface that lets you control easily your robot, and we do that by plugging the Ethernet cable to a computer. Then we open a navigator and type in the IP address of the robot. Then control and activate our robot. From there, we can easily open our saved program for this demo. But before we start the demo, let me do a quick tour of the interface. We first have, on top the setting bar, the jogging panel that let you jog the robot either in Cartesian or in join, or control the Smart I/O module. Then the code editor for writing and editing new programs. The 3D view let you see in real time the robot's behavior. Finally, the event log. And now let's start the demo. As you can see here, we have a time remapping feature that let you control in real time the speed of the robot. We can have a closer look at the program. In here, for instance, we have set the desired values for our vacuum settings like the purge duration and the threshold. We also set up the parameters for the jump commands like the jump height. We can also see here the commands to set up the 8 outputs of the I/O module that we can also control manually in the jogging panel. That was it for me, and now back to Sam.
What a beauty. Now, enough of me. Let's meet our panelists. But before we dive into that fun part, I'll invite each of them to introduce themselves, their company, and share their key takeaways from their experience as MicroDASH MCS 500 beta testers. Our first guest is actually live from France, so please give a warm welcome to Maxence from Precipio Robotics. You can unmute and open your camera. Please give us a quick intro about Precipio and your role.
Real pleasure for me today. First, thanks Mecademic for the invitation. So I'm working as a robotic R&D engineer at Precipio Robotics, which is a French company realizing automation in the domain of microassembly and micro-manipulation. I would say our know-how is based on patented piezo gripper, and these grippers allow us to manipulate objects with sizes between 40 micrometers to a few millimeters. And we'll see more just after.
So then, as part of our early access program, your team has done several tests on the MCS 500. What important key takeaways can you share with us today?
Yeah, exactly. During the testing, we performed several tests to evaluate the accordance between the SCARA and our application. So we mounted our gripper. This is in the video, you can see it. And we realized pick and place of objects such as a needle of 40 micron diameter and a resistor with a width of 500 micrometers. And I would say in the same time, we perform also analysis of the cycle time and positioning repeatability in several points of the workspace to evaluate I would say the open loop without vision feedback. And moreover, I would say the design and the compactness of the new SCARA is really an asset when many other components are needed for the manipulation, such as cameras or so on. So I think the SCARA, the repeatability, this compactness, and this speed will definitely help us in our future applications.
Thank you so much for that. Again, if you guys have any questions for the panelists or for us, don't forget to use the Q&A feature. Now, straight from North Carolina, US, please help me welcome Rob from Seymour Advanced Technologies with a quick intro and what Seymour does.
Hey, hello. My name is Rob Seymour. I'm the CEO and founder of Seymour Advanced Technologies. We're a custom industrial automation machine builder here in the southeast of the United States. We are a fully integrated company that uses a lot of 3D printing in-house, both for metals and for plastics, along with a CNC facility. We make the parts, we make the machines that customers require not to fail. That is for the aerospace, life science, electrical assembly, and some military applications. We have a full traceability in the parts that we process, continuous monitoring, and data logging. We do all in-house applications, anywhere from design, manufacturing, build, test, and install.
Thank you so much for that. Now, compared to what you have worked with before, what did the Mecademic-SCARA solve that other comparable models couldn't during the beta program this summer?
Yeah, the Mecademic, the SCARA it's a complete package. It handles everything. It's easy to use, just like a cell phone. Pretty much self-explanatory for the user interface. It's definitely picks up speed. It can be vertically, can be inverted for mounting. We had a razor application for a customer for placing these in packaging, and it overperformed. And for industrial automation, when you get some more bandwidth in your products, it always makes the complete package better.
Thank you so much. Yeah, we're definitely loving those features too. Last but not least, straight from Italy, we have Fabrizio from Nimo. Fabrizio, you know the gist?
Hello, everyone. Thanks a lot to Mecademic for the invitation, and thanks to the audience. We are Nimo. I'm Fabrizio Buriero, the CEO. So the Nimo started as the consequence of my career. I come from academia. I had a PhD in robotics. And at a certain point, I started to do consultant, freelance consultant for a company that work in the watch industry. So my area is watchmaking, jewelry, but now we also work with micro mechanics. 4 years ago, I founded Nimo. Now we are a team composed by UX designer, mechanical engineer, electrical engineer, and we produce tailor-made machine as the machine that you see here. So we, from the idea to the finished machine, the complete machine, we do everything in the house, but we are focused on tailor-made machine. Thanks to Mecademic, we have the possibility to access to this early access program. And as you can see, we work a lot with computer vision feeders to handle small parts. And the benefit of the early access program was to show to other customer a novel product which is outstanding. The speed is very, very good. The dexterity of the robots is awesome, and we were able to reduce a lot the cycle time of our machine. So yeah, we are very happy about this new product.
Awesome. So just cognizant of time, quickly, I know Nimo built a watchmaking application. So tell me, what surprised you about your experience using the MCS 500 SCARA within your industry?
Yes, as I said, first of all, the speed, because the easy way to integrate this robot in the machinery. Also, sometimes we have a customer that ask us to put the robot inside the already done machine, and Mecademic robots are great on this. But in particular, the SCARA was very impressive about the precision, the speed, and the possibility to control the rotation of the z-axis. So we working with computer vision allow us to pick more pieces and reduce it a lot the cycle time. So that was really awesome.
Wonderful. Thank you so much, Fabrizio, and Rob, and Maxence for those insights. Please stay online with me. Keep your cameras on, your mic on. But before, I just want to launch a quick poll. Your turn. I'd love to hear what your current challenges that you're facing in your automation projects. And while you do that, I would like to invite Stan, our Director of Applications, as well as Louis, who will be moderating today's panel. Curious to see those results. Nikki, can you pull those up? Oh, budgetary constraints. We might be able to help you there. Louis, are you surprised about our audience's answer?
No, not at all. Like for the quality of our SCARA, the price point is really really strong compared to the market. And that other one regarding high mix, low volume, really we see a lot of projects with the MCS 500 where it's going to be coupled with a flexible feeding solution. So we're going to see a lot of that for unscrambling. So of course it's a SCARA like the one from Mecademic is a key component to deal with the high mix, low volume tendency, which applies to a lot of industries these days. So thank you, Sam, for this great presentation. So at Mecademic, everyone at Mecademic has been seeing the new SCARA run in our testing facilities for a few years now. We've also had some key partners, key customers test it in application-specific use cases. So needless to say, we're all extremely excited to start seeing it in full production customer applications. That's just about to happen in a few weeks, so everybody is thrilled here at Mecademic. So for my part, I take care of Mecademic's activities in Europe. For that reason, I've had the chance to work with Nimo, based in Italy, and Precipio, based out of France, on cutting-edge micro automation applications. I've also seen the very impressive machines built by Rob and his team using the Mecha 500 robot arm. So those three companies are probably some of the most qualified machine builders Mecademic has had the chance to work with. So needless to say, we're all very excited to see the problems these guys are going to solve with our new MCS 500 SCARA robot. So a product presentation like we did is fantastic. I mean, it's great to know about the robot's physical capabilities, but we have to keep in mind the robot arm is really part of a system. It's probably the most important component of the system, but it's still just a component. So my goal here with our four panelists is to take a step back and really have a broader view of the whole system, and of course, how the system integrates to robot arms. So for that purpose, Fabrizio, Rob, Maxence, and Stan, I'll ask you guys a few questions to allow the audience to benefit from your expertise. So first question, so we always have to remember there are other options to using robots. You can also do what we like to call custom fixed automation, having a machine built really tailored to your process. So that can be the way to go if your process is never going to change and everything is going to be fixed. So I guess my question for you, Stan, to open up with is how often will you develop a custom fixed automation solution versus using off-the-shelf systems like robots?
Yeah, well, this is something actually quite common. So for the Mecha 500, what we saw is that, not everybody actually needs the 6 degrees of freedom of our robots. And this goes into the whole kind of bigger debate between like hard automation and flexible automation. But what we found out is that a lot of customers, if they just needed the 3-axis XYZ, they were still putting in the Mecha 500 robot into these applications, just because for them, it was easier to basically source the robot. The lead times were quick. They're already used to running the robot in other applications. So it's very easy for them to integrate it. And then, it's just a more flexible solution. So if they're building different machines, in some cases, yes, they only need the 3-axis, but in others, they also need the rotation. And that's sort of where we came about to the SCARA robot, because we'll be able to offer that same kind of XYZ with the same kind of intuitive programming interface as the Mecha 500, but you're also able to reduce the cost and simplify the system. So that actually came a lot from the demand of current customers. So it's not every application that will necessarily need a robot, but there's really a lot of advantages to having the SCARA and the Mecha 500 as part of the overall portfolio.
Yeah, really interesting. So even though you don't really need 4 or 6 axes in some cases, it reduces drastically the amount of mechanical engineering you have to put into
the work that you have to do. That's let's say the SCARA robot is maybe a little bit more expensive than, sourcing your own axes and doing the controls, but you have to take into that the engineering time that it's going to take you to set all that up as well. So in a lot of cases, if the robot more or less fits, even if it has more features than you need it, sometimes it is worth the investment.
Great, thank you, Stan. So anything to add from the other panelists?
Yeah, on top of that, I'd also like to add that you add in or keep the quality from Mecademic. You can stack a bunch of servos on top of it, make yourself a gantry, your parts and pieces. But with that comes the probability of other issues popping along. So to be able to put a Mecademic in its place rather than the SCARA or the 6-axis to solve smaller problems, it's an all-in-one package.
Yeah, exactly. So instead of having your company, your guys take the heat, leave that to Mecademic. So we've tested the product in-house for a few years. So of course, the probability of having mechanical problems is lessened by using a turnkey motion system like a robot arm.
Exactly. And we're doing the motion control as well. So, that you don't have to get more expensive PLCs necessarily. That's all handled by the robot at the same time.
Yeah, it just keeps adding and adding and adding. Where you get the robot and you just put it in place, you mount it, you already know the program with it and what it can do, and off you go.
Yeah, exactly.
Great.
I want
Well,
I want also to say that the maintenance is very important because if you have a very complicated machine and it's stopped, you stop the production line. Sometimes just taking a robot away and putting another one, like in half an hour, you have the machine running. We had a problem like this. Was not a fault of the robot, but was a fault of the operator that broken the robot. And but instead of waiting 1 week to fix the machine, we just changed the robot, and in half an hour the machine was working. It was a great advance, and the client was super happy about this.
Good. Well, thank you guys. Very good feedback. So my next question is maybe a little bit more abstract. I know for a fact that Mecademic, we win a lot of big deals simply because of the space saving factor. So we do make the world's most compact robot arms on the market. So my question for you, Stan, is how would you evaluate the financial value of space when designing a machine?
Well, I mean, you always have to. We work globally, so there are some areas where space in a factory might be less expensive. There's some areas where it's very, very expensive, especially if we work in lab environments and in clean rooms. The space there is, you could finance the cost of a robot by just it being small, basically in some clean room environments as well. But the whole idea of it is it's not usually just one robot, right? So maybe one robot by itself compared to one bigger robot is not going to be critical. But once you start having these production lines, and because our robot, the robot itself is quite small, but you also have to think all the components that come around it. So our embedded controller, versus other manufacturers, even servo drives, they have external controllers, and that adds a lot. So while I could make an automation line, with like 5-6 robots on my desk here, if you're trying to do that with bigger robots, that becomes a lot more cumbersome, and you really have to invest in having enough space for them. And the other thing to consider is that a lot of the times machines that have been developed in the last decades were designed bigger to accommodate these bigger robots. So that the cell had to adapt around the robot, and we're trying to go the other way around. We're trying to make the robot adapt to the size of the cell, to the size of the parts, because it's quite often that I've seen, you're lifting a part that's a couple of 100 grams, but the machine to do it takes up, half a room, just because the robot that they're using is significantly bigger, or the components in it. So we're trying to fit into, especially if you consider some applications in optics where it's a tabletop mounted system. There's not many other robots that could fit into this kind of environment. So we're really just trying to fit into smaller places wherever we can, because a lot of the machines some machines are already existing, and they just wanted to add a little bit of automation to it, and they can't really do that necessarily by adding a big robot to it. So this is where the Mecha 500 and the SCARA really have the biggest advantage, is the overall size. So not just the size of the robot itself, but everything that comes around it. And this create so much simplicity in terms of shipping as well. I mean, the logistics with our robot is minimal because it comes in a little box, like an Amazon-sized box that's delivered to your house within a few days, or your factory, obviously. But that in terms of shipping for global companies that we work with, if they have to ship robots all over the world for different facilities, the logistics costs are so much less, and it's just much easier to work with when you don't have so many things around the robot that are very difficult to manage.
Very good. Thank you, Stan. So anything to add, you guys?
Yeah, I will add the Stan said that one of the most important things also is the controller size, which is embedded with the robot, and so we save a lot of space also on the hidden part of the machine, and it is very important also for when building machines, especially for an application.
Yeah, and I know, for instance, I've seen like there's like tiny hexapods in optics, but they sometimes have these huge controllers. I was really impressed when I saw.
Yeah, exactly. And in automotive, we've also seen some projects where the production can be very cyclical for those companies, and they're going to build a factory space with respect to the current demand, but sometimes it can boom. So for those guys, really to have the same production capability in a small space without having to redo a new factory can be worth millions of dollars. So really, this is really interesting business cases as well for using smaller robots. Good. So anything to add, guys, or can I move to the next question? So great, thank you. So at Mecademic, it happens sometimes where we're going to do some client visits, and the parts that they need to work with are so small that you can't even see them with the naked eye. So of course, it's obvious that working with those parts takes a special set of skills. So I guess this is a good question for you, Maxence. So what specialized knowledge do you consider essential for the smooth integration of a micro automation system?
Yeah, thanks. I will say, first of all, we need to learn the new world in which we are working. For example, at Robotics, most of the parts are below 1 millimeter in size. So it is a completely different world. The gravity is not the predominant forces. And so learning everything of this is very important. And if we can save time by, I would say, controlling the displacement by using robots, small robots, it's a huge saving time, and that's it. So also I would say that at this level, with this size of components, we are facing some trouble with the components which are sticking to the grippers and so on. So there is a lot of things to learn, and if we can save time on the moving part, it's a very good benefit.
That's very interesting. So I think it's a very powerful statement that gravity is not the dominant force anymore. So that really shows that it takes a special set of expertise. Thank you, Maxence. Anything to add, guys?
Yeah, so like the size is definitely it, but I think some of like the tolerances on it. We do small parts, but we got to put them in also small places. With the one application, we were putting wire in the 25 gauge needle. Had 60 microns of diametric difference, but had to be coaxial when they go in. And yeah, so small is one thing, but trying to place it or locate it and still have those small tolerances, the Mecademic definitely plays off.
Yeah, exactly. So the nominal dimension is something, but really the most important thing is the mechanical tolerances. Yeah. So thank you, Rob. Okay, so on to the next question. So I'm going to take a software turn. So obviously software is essential to get the machine running. Everybody has a new communication protocol, so it can be confusing to figure out what's really needed, what's essential. So I think that's a good question for you, Fabrizio. Could you share the difficulties you've encountered in getting different hardware components to communicate effectively in an automation project?
Yeah, sure. As integrator, we don't just program robots. As Stan said before, we put a robot in an environment, in a context, and most of the time the environment is very heterogeneous. We have a different brand, of course, different field bus. Every producer make his own communication protocol and so on. And for an integrator, it could be a nightmare. So we have to be very, very reactive to study a lot of protocol, a lot of things. So of course, putting the things together is the main challenge for a robotic integrator. But I think that the main problem that we solved as Nimo was the synchronization between all the hardware, because it's fundamental, the synchronization between the machines, not only to reduce the cycle time, but to do also some tasks that cannot be possible. As an example, I just have here a sample. We integrated the Mecademic in a laser engraving machine. So we had to synchronize the laser head with the last joint of the robots. So I was able to rotate the ring, and so I was able to write with the laser on the ring. You can think that you cannot achieve this without a great synchronization. And to us was great the Mecademic robots that are able to control with EtherCAT, which is a very nice protocol. And but also sometimes we also use the CPP because sometimes the other brands don't have. But yeah, we use the PLC, so we really can interact with all devices with this robot. And yeah, so I had a great advantage on this, but again, I think that the synchronization between the heterogeneous hardware is the most challenging part.
So Fabrizio, you mentioned that sometimes you use TCP/IP, sometimes you're going to use EtherCAT over backup. So what makes you decide? Does this come from the customer, or does it really depend on the technical requirements?
Well, it depends. When we build the machine, so we start from zero, we can choose, okay, I put all the driver I want to be slave EtherCAT, so I put everything in EtherCAT chain. At that point, I have the maximum synchronization, the maximum, the maximum performance of the machine. But as I said, sometimes there is the already done machine, and they ask me, can you put a robot inside? In that case, we use other protocol, but we have less performance. But of course, we are able to integrate in a very easy way. So we reduce the cost, and we don't have to buy like some proprietary hardware to run the robot. It's very easy to integrate.
Okay, very good. Thank you. So I think this is an open question for everyone. So of course, there's different robot arms out there. It can take a lot of time to get familiar when you have a new project with a new robot. I guess my question is, how do you see the diversity of robot control systems impacting the integration process?
I could probably start on that because I know that's something that's been bothering me for a long time with robotics companies, right? They all have their own. I used to work with another brand of robots, and they all have their own proprietary language, and every single brand has their own proprietary language. And then there's other companies that try to make a universal programming language, and that just adds another language that you have to learn. So yeah, that's one of the things that when I joined Mecademic 5 years ago, it was the fact that the robot is adapting to what you already know. So if you're, I guess Rob is more of an Alan Bradley programmer, for instance, let's say, the robot will adapt to him. Fabrizio's EtherCAT, Maxence, I think you use mostly TCP/IP, right? So we're just trying to get as much as we can that already exists in the world. And this is one of, I would say, the top features of the Mecha 500, and we're pushing that obviously to the SCARA as well, is that it natively supports all these protocols. It's not a paid option. You don't have to get a special hardware. So that's why it makes an important tool for you to have, because there's some integrators that use different PLCs because the customers are speccing different PLCs in their facilities, and it's the same unit that you could take. And I want to use Profinet because I have Siemens in this case, and it's a command that I enable Profinet, and you're able to run it with Profinet at that point. So this is really that's something that differentiates us from a lot of other companies. And again, we're not trying to do like a universal programming language, or we're not having necessarily. We have our own set of commands, obviously, but they can be sent through different types of controllers.
Yeah, so you really have the proof here. So I think it's interesting. I didn't even notice, but you have 3 companies that are going to privilege 3 different ways of working with the robot. So one Allen Bradley, one Beckhoff, one TCP/IP on PC systems. So it's the proof that it really works. You can use whatever you want to control our robots.
Yeah, I'll add something into that. You know, for programming, it's very diverse. But also with like more mechanical background, we can actually go in there and take it offline and program in it to see it operate and come back with a list, a printout, be like, hey, get the controls engineer, hey, this is the operation I needed to go, at least to start them somewhere. It is like I said, it's like cell phone easy. It tells you how to do it. Very, very intuitive, and that helps other people be able to get involved with it. Can take it, put another one on their desk, learn the program, know what it can do, so you can design to it and not hope it can go at the end.
Yeah, and then it's a lot. That's why a lot of the times, actually, a robot is interesting because it's also used in the process development stage. So a lot of times, for other robot manufacturers, the process is developed separately in an R&D lab, and they're using a different technology, and then it's put into production with industrial robots. For us, it's basically the same robot that stays from the line. So they'll use it in R&D, because even if the people doing the R&D don't have robotics knowledge, it's, you know, after a few hours of training with the robot, they're able to get it up and running and do what they want it to do. And then when it gets to the, you know, to the operations people, and then they're implementing it into their production lines, and it's the same robot. So it's a more consistent kind of process development to final assembly.
Great, thank you guys. So yeah, sorry, Maxence.
Yeah, if I can add something, just to say that we live with Mecademic robots. It's the robot which is adapting to us, and not us adapting to the robot, and that changed a lot of things in the integration.
Yeah, exactly. So when I started with Mecademic, that was really one of the main things for me. So you can really the user uses what he's already familiar with. So that's really a game changer in terms of robotics.
Yeah, I just also want to say that Nimo was born in 2020, just 3 months before the lockdown. From that period was a mess about the parts. We were able to have the parts. We have to change a lot of things, but was very great because the robot, also if we change it, sometimes we change the PLC, sometimes we change it because, you know, there were nothing around, so we had to adapt to what we were able to reach on the market. But was very useful, this idea that it was really easy to change the brands and again be able to make machine and sell machines. And if we are still alive, is also thanks for this possibility.
Yeah, of course, if you're not locked in with a specific way of doing things, of course, it can make the difference between having a machine sit on the factory floor for a year versus, okay, moving on to the next project. Very good feedback.
Yeah.
So thank you very much, guys. So I think we have some good questions from the audience as well. So I'll go through them. Hopefully Stan will be kind enough to help me with them.
I'll do my best.
First question, the vacuum module is interesting, especially because of the digital I/O. Is this functionality going to be released for the Mecha 500 as well?
That's a good question. We were sort of expecting it when we released it for the SCARA. Unfortunately, not in the shape that it is now. We can't do that. The SCARA robot has really been designed from the ground up and it was modular, so it's made to accept it. The Mecha 500 was developed, 7 years ago, so that's not directly pluggable. There's a lot of options on the market though. So we do, if you're just using TCP/IP, we do have recommendations from remote IO modules that you could use. And obviously, if you're using a PLC, you could use IOs from the PLC. So the module as it is for the Mecha 500 is not compatible. That being said, all future generation of Mecademic products are going to be based on the SCARA platform. So I can't talk about anything more than that. So whichever robot we make in the future, whether it's smaller, bigger, different type, that would have the capacity to support something like an IO module.
Thank you, Stan. Another question. So what is the maximum force the Z-axis can apply? Can this be used for a light pressing application?
Yeah, so as a SCARA robot, it is made for assembly in some cases. We haven't tested the maximum. So for now, let's stick with the 1 kg, 10 Newton kind of pressing that you can do. We haven't tested fully to the limits of what it could support, because it's also going to depend on how long you're pressing it for. So the duty cycle of that press. If you're doing, if you're doing something very quick, then obviously you could exceed it a little bit more. But if you're holding it down for a long time, that's a different level. And this is going to be something that we'll provide in the specs eventually.
Thank you, Stan. So the position, repeatability, and Z for the SCARA.
So surprisingly, I actually thought it would have been worse than the 5 microns, but it's actually, because usually those kinds of shafts have a little bit more of backlash than the harmonic drives that we use for the other one. But we're actually seeing results very close to the 5 micron range, sometimes better. So that's actually 5 microns is a fairly conservative value for us. It's much more important in the XY plane for a SCARA robot. But to put it in perspective, the Mecha 500, which had 5 microns of repeatability at 500 grams, we're using encoder resolution that is about 18 times better in the SCARA. So theoretically, we lack the instrumentation right now to go below the 5 micron precision measuring range. So it's a fairly conservative figure. And I think maybe Maxence was a part of your team. And I think we had somebody else test the repeatability as well. And they're really close to the Mecha 500 or better in a lot of cases.
Good. So a question from Brian. Is vision guidance and camera to robot coordinate calibration a straightforward procedure?
So we don't make our own cameras yet. So a lot of that is still on the camera side. But from our experience, especially with the SCARA, it's much simpler in terms of the coordination or how you align the reference frames. I know we use the Nazero flexible feeder, and they have a really good software called I+. So their package, the I+ package, which comes with the camera and the feeder. I mean, that kind of calibration is fairly automated, and I think it took us a couple of hours to get it working with the SCARA for our prototype demos. So it's really depending on a lot of the times on the software of the camera that you're using.
Thank you, Stan. So a question about the Mecha 500 slipped in, so I guess we can answer it as well. So does the Mecha 500 have a clean room certification?
So the Mecha 500 does. So every Mecha 500 is certified for ISO 6 by Fraunhofer. We've seen it used in much better quality, much higher levels of clean room as well. So we've had it run in ISO 4 clean rooms quite often. Because mostly it's joint 6, because it's open, that'll generate the most particles. So in the Fraunhofer test, for instance, it's mostly if you're continuously spinning joint 6, that's the one that generates the most particles, and that's why we're ISO 6. I could answer it for a little bit for the SCARA as well. So we haven't rated it yet. It's something that's in our plans, and there is provision. So you'll see that the shaft right now, there's no bellows on it, but there's provisions to add bellows, because the main thing is that the shaft has to have grease on it, and that's what's going to contribute to the clean room requirements. But you'll notice when you get your first units that there are bellows that we could attach, that there are whole provisions for bellows on the SCARA robot.
Great, thank you, Sam. So a question about life expectancy. So what is the life expectancy, and what is the maintenance to be done on the MCS 500?
Okay, so right now we're qualifying it the same as the Mecha 500, which is at 50,000 hours MTBF, which are based on the harmonic driver, which are the most critical components of our robot. In terms of maintenance, there's a little more maintenance. So the Mecha 500 is completely maintenance free. Again, because we're using the shaft on the SCARA, there has to be grease applied. And we've already have a provision in the code that eventually we'll be able to track the amount of travel that Z-axis moves, and then that you'll be able to have like predicted maintenance on that in order to apply, because we can give some figures about, you know, like it's in the manual about how often we could change it, but it really depends a lot on your application. You know, if you're only running it a little the Z-axis a few times a day, it's completely different if you're running it continuously. So yes, I could tell you, okay, we'll change the grease every 6 months, but it's much better once we'll have it implemented in the software to tell you, okay, well, it's run, you know, 100,000 kilometers or something, and now it's time to change the grease on the Z shaft.
Thank you, Stan. So that's all the questions we've had. Of course, if any other questions pop up, you know where to find us. Simply contact us on our website. We'll be happy to help you. So now I'll hand over the presentation to MC Sam for the conclusion.
Thank you so much, Louis. Really appreciate it. And thank you so much, panelists, for being here with us today. So to wrap things up, the MCS 500 is a next generation SCARA robot with exceptional precision, compact design, versatility, and user friendliness. And we've seen how it stacks up against the competition in ways that matters for micro application. Another important key takeaway, Mecademic Robots adapts to you, not the other way around. Thank you for that, Maxence. So if you're interested in learning more or discussing your automation challenges, please let us know in the poll. So thank you so much for being here with us today. We learned so much, and I hope you did too. So before we let you go, I want to take the opportunity to thank Fabrizio, Maxence, Rob for being here. It was such a pleasure to have you guys here. And it was also a great opportunity for us to introduce you to our expert network that can help you leverage Mecademic robots for your automation needs. So with that, I wish you a fantastic rest of your day, evening, or night. Talk soon.